This question looks slightly different kind of nature because they're asking for derivatives, but let's go read the question first. Hyperbola is given. This is a rectangular hyperbola. You know, you can just quickly draw the hyperbola first. Vertex, right? Okay, what is this point? Just plug in y is 0, right? You get x is plus and minus 1. So this point is 1 comma 0. Okay, let's read more. A circle S with center, what is x2 comma 0? I don't know where is x2, but I definitely know that you're on the x-axis. The center is on the x-axis. Let's read more to see. Suppose that H and S touch each other at the point P. Okay, what is the point we have to see? X1 is greater than 1. Okay, so somewhere this side, okay, more than 1, and y1 is positive, maybe somewhere here. Okay, that's your point P. The coordinate they have given is x1, y1. Now H and S touch each other. Okay, so the center should be maybe somewhere here for the circle. Okay, the center they are saying is n, x2 comma 0, that's the center. So this is the radius then. Okay, and you can complete the circle if you want, something like this. Yeah, okay, let's read more. The common tangent H and S. H is the hyperbola and S is the circle. Okay, the common tangent you have to draw at P. So let's draw a common tangent. Okay, so let's say this is my common tangent. They are saying it is intersecting the x-axis at the point M. So this point is M. LM is the centroid of the triangle P, M and N. Okay, let's complete that. P, M and okay, it's already completed. So this triangle, they are saying that the centroid is L and M. Now, which of the following expressions are correct? Now, you see that they are trying to find derivative of L and M in all the four options. So, get L and M in terms of what? X1. Okay, once you do that, you can find the derivative, right? So, what is the coordinate of M? Can you get the coordinate of M? Write equation of tangent to the hyperbola H. How does it look like at point P? X x1 minus y y1 is equal to 1. That's the tangent. Now, to get M, what do you do? M is on x-axis. Okay, so you have to put y is equal to 0. Okay, so put y is equal to 0, what do you get? X x1 minus 0 is 1, so you get the coordinate of that point is 1 by x1, x coordinate. Okay, because y coordinate you know, right, it is 0. So this you already got that. Okay, M in terms of x1. Now we want even N in terms of x1, you see. Okay, because x2 you can't see anywhere x2 here, right? So I don't want x2, I want x2 in terms of x1. Okay, let's go ahead and do that. So Pn is the normal, correct? So Pn is normal. So can you write now equation of this normal? It is passing through the point x1 y1. Okay, so point slope form y minus y1 is equal to m times x minus x1. What's the slope of this normal? What's the slope of this tangent? You see that? Slope of the tangent is x1 upon y1. That's the slope of this tangent. Okay, you know, right? You can just convert it into like y1 is equal to x1 minus 1. Okay, so you can divide by y1. You can divide by y1. Okay, y is equal to mx plus c. Okay, so this is your m. And for the normal, it will be negative reciprocal. Okay, so let me write that. This is what you're getting. Negative reciprocal of that. Okay, now to get n, what do you do? Again, n is on x-axis, so you have to put y is 0. So put y is 0 here. So 0 minus y1 is equal to minus y1 upon x1, x minus x1. Okay, so what next? Cancel this out. You get x minus x1 is equal to x1. Okay, so you got your x to be 2x1. Okay, so that means the coordinate here is 2x1. You got x2 to be 2x1 basically. Okay, 2x1 comma 0. Okay, almost done, right? Because now you want to get the centroid. What's the formula for centroid? X1 plus x2 plus x3 by 3. Okay, that's the x coordinate. Okay, so let's write that. Okay, my x1 is x1 only, x2 the n coordinate. Okay, plus x3, that's 1 by x1. Okay, divided by 3. What is this? This is L, right? The x coordinate. And what is M? I don't know if we need M. Yeah, we do need M. Let's write that. Okay, x y1. Okay, what is y1? Okay, because y1 is what? We are lying on this parabola, right? So your y1 square is equal to x1 square minus 1. Just plug in. Okay, x1 square plus y1 square is 1. So your y1 is under root x1 square minus 1, correct? Y1 is under root x1 square minus 1. You're in positive quadrant, right? So everything positive. So y1, okay, so y1 is x1 square minus 1. plus y2. The rest everyone is 0. Okay, y2 and y3 everyone is 0 divided by 3. Okay, so we got L and we got also M. Okay, now what do they want from us? Let's do the first one. You have to find the derivative of L with respect to x1. Let's do that. Find the derivative. 1 by 3. Okay, so first derivative, okay, this is 3x1, right? So let's write, this is 3x1. Oh, okay, more simplified. You are getting just 1 upon 3x1, right? Yeah. So okay, everything out. So this is 1 minus 1 upon 3 x1 square. Oh, good. So you got A to be the correct option. Of course, then B cannot be correct. Sorry, C cannot be correct. Done. What next? Let's do this. Okay, dm upon dx1. Okay, let's do that. dm upon dx1. What's the derivative? 1 upon 3. Derivative of under root x1 square minus 1. 1 upon 2 under root x1 square minus 1, and then you will be having 2x1. So 2 gets cancelled and you are left with x1 upon 3 under root x1 square. Okay, so this is correct. Okay. D is just looking with y1. Okay, so m actually was what? Y1 upon 3. Y1 we replaced by this. Okay, the derivative of m with respect to y1 is of course 1 by 3, right? Because this is the formula you have. Okay, so this is also correct. Nice question. Not difficult at all, right? Okay, see you with another one.